Hello guys, how are you? I'm sorry for the delay with my tutorials because of my busy schedule. So let us continue with the tutorial series. So till now I hope that you have already done much of your practice with the basics of Eagle based PCB designing, that is right from schematics to making the layouts and finally creating the Gerber files. So the main motive was that you should understand the basic design flow and you should be able to make some small circuits, that is the working circuits of course. So moving towards a bit complex designs. So today I'll be covering one circuit, though that circuit would not make any sense, but I would try to cover some different variety of components to give you a feel of how exactly a PCB would be designed. And next we would be doing some high-speed optimizations and stuff like that. So let us continue with this tutorial. So just like the previous ones, let's make a new folder within this folder. So for that we need to first of all open this project. Okay, and then I'll say that I want to make a new schematic, or what I'm thinking is instead of it's always preferred to have just one project within one folder, and you can just say new project and say tutorial 2, and here you can say new schematic. Okay, so basically I want to cover a circuit which contains an IC and some connectors, and for connectors for power supply and some coaxial cables and all those stuffs. So let me see if I can do for op-amp. So let us do for op-amp. I think that will be better. So let me see. uh, One of the alternatives is that you can always go to this IC package. So in this IC package you see all these dual inline packages, right from two pin ICs. Though two pin ICs I have never seen till now in my life, but still they have it here. From 2 pin to multi pin ICs which can go up to 40 to 64, and obviously now you already know how to create your own chip. So if it exceeds this value, then you can always make your own IC package. So maybe I'll be discussing about one more design, uh, provided I get good feedbacks. I will be making one more design of IC based tutorial. Okay, so let us take an op-amp. So let's say 741. So let's take this one. So let's keep it over here. Okay, let's make a amplifier. So for amplifier we would need a resistor. So basically you can always go on clicking R and find resistor over here. Now what I'll do is I'll cover an SMD package this time for a better feel of how you can design, so that if I take an SMD and this IC is a DIP, so how you connect SMD with DIP, so you get a feel of that thing. So generally we for SMD we either take 0805 or 0603. So let me take 0805. So let me keep it over here and let me keep it over here. So we'll be needing 3 resistors. Okay, so press escape. Okay, now for power supply we would be needing a VCC or VDD and VE. So let's say take VDD. You need to go into supply SUP or SUP. So you need to go into supply, take VDD. Okay, or you can even take plus 12. It does make sense to take even plus 12, and you can take minus 12, right? Alright, now moving towards some, before doing connections it's always better to align the diagram as per your requirements. Okay. So it goes like this. This one will be keeping it a little bit down. This one you can keep it up because I need a feedback. Okay, so I am doing a quick connection. I'll be needing an input. So for an input I'll be using con. So con basically means connectors. So there are number of connectors over here. You need to choose connector as per your choice. So always it's better to go into con amp quick. So this is what which is the male female connectors which are generally available in market. So for input we'll be requiring an input with respect to a ground, so we'll be taking that. Okay, so I connect an input with respect to a ground. Now this one, for this I'll be needing one ground connection, so let me take that ground connection now. So again I'll be taking this, I'll be going to ground, or for ground you need to again go into supply. So inside supply I'll be taking ground. Okay, so I did the ground. Okay, so for now I am making a basic op-amp, so let me not use this resistor just for making things quickly. Okay, now this one should be connected to ground again. So always I prefer to have these connectors in the joining points. Okay, so I think our circuit is almost ready now. Anything left? 6 is the output. Okay, so for output, suppose I want a coaxial cable. So again for coaxial cable I want to go into con. Now here you need to see for coax. So con coax, inside con coax I would go to SMD. Okay, now here the center point is the coaxial feed, while the other one is the ground. Okay, so until and unless you make a physical connection over here with such type of junction, till that time it's not connected. So you can see here I'm easily moving it, but if I connect this junction over here, it will ask you that whether you want to connect it. If I say yes, then it means it will connect them. Okay, then you can't separate it. So always make sure that if you want these type of connections, you should always have a junction, because in bigger circuits these may not be important. Okay, so don't take this circuit as a final circuit, because I'm just using it as a random circuit. This op-amp connections may differ as per the ICs, and the various ICs may have VDDs and supplies as per their data sheets. Okay, now moving towards the other part, that is schematic. Okay, now again I'll first bring all the components and place them as per my need. Now you can see that since these are SMD connectors or SMD resistors, sorry, so since these are SMD resistors, so they will appear as a top layer. Okay, so we want to make it as small as possible always, because that would certainly reflect on the cost. Now since I don't want this big name over here, what I'll do is I'll click on smash and I'll delete this. Okay, so I think things are pretty much done now. Are all the connections as per the needs? Oh yeah, we missed the VDD ground. So this one would just create the nets. Okay, so if we want to make if you want to give a supply to the circuit, we would need further a connector which would be connected through the external power supply. So again I'll be going to this quick. So we will be needing a VDD, ground and a VEE. So I can just copy this and create this point over here. I can again copy this and I can copy this, so that now I can give power supply from the external source to my circuits. It's always a good habit to have these junctions placed, though it's not so much necessary if you are doing things as per the rules and you know what you are doing. Alright, now the supplies always should be placed right at the corner of the board, uh, because it helps when you do your testing and stuff, so that because you need to always take care that the supply thing should not interfere with other parts of the circuits, like it should not short with any pins or do some nasty things which would create a big shock or something like that, big spark you can say. Okay, now I am deciding the area of my board. So what I can do is I can have this much area. Now this part is something which is decorative. It doesn't reflect on your board, but since it's the package, we can't help on that. It cannot be removed. One way is that you can create this on your own in that way. So still it's a bigger one, so let's make it more smaller. Okay, and this one is I think good enough. Okay, now we'll click this rat nest, so things will be optimized as per our needs, right? All right, now the major challenge here is that we need to connect this, which is SMD, which is a top layer, to this, which is in bottom layer. So how do we do that? We do it with the help of a wires. So let us first take this route. Okay, let us move from here. So since it is top, now it's always better to have width of 0.06, but for SMD, since we have taken 0805 package, 0.6 would be a bigger one, so 0.5 still bigger one, so 0.4 would be good enough. Okay, now see, there are two ways of routing. One is you can go directly 90°, but going directly 90° creates loss of current related problems in this corner, because it may cause some current flow problems and some losses, causing some inductance, capacitance effects and all those things. So it is always recommended to have some angle, about 120 degrees of angle, in order to have a good current flow. Okay, now since you can see that I didn't change the grids, because therefore I am facing lots of problems in terms of routing. So I'm coming to and turning it to 0.01 as usual, as we did in previous tutorial. Now you can see we can go smoothly. Okay, now we need to connect this to this. Okay, so I am choosing this width as 1.16 deliberately, because I'll be discussing about this thing when I discuss about high-speed design. So these are some of the rules which takes place in a high-speed design, which I'll be talking about later, so let's not talk about it right now. Now this is a bottom layer and we need to connect a bottom layer to a top layer. So what I'll do is I'll just bring till here, I'll make a click, and then I'll go to bottom and I'll connect it over here. So what it has done is it automatically creates this wire. Okay, now I don't want a rectangular wire, rather I want a octagonal wire because that looks good. So I'm changing it to octagonal wire. Alright, now moving towards the other routing, that is this one. So we should not have a via within the IC pad because via is a physical connection and that would require some holes, or if you are doing homemade PCB you would be requiring external wires to be connected through hole so that you can do the connection from top layer to bottom layer. So always it is recommended that vias should be outside. So what we can do is we can connect this over here presently. So let me take a bigger width because it's available with us. Okay, let's do this connection now. Since both of them are bottom, I am taking a bottom connection. Okay, now this is a ground, right? So we don't need to do a ground connection right now. I'll be talking about it a little later. Let's complete these connections. Now since this is a IC package, we can bring the wires from below. Okay, something like this, and this is two connections are remaining, so let's complete that. Now since this is a bottom layer, we need a bottom and a top. Okay, sorry. So this is a bottom layer and we need, so let's bring it till here, and then we need a bottom layer. Even there is no any problem with using a square, but I like personally octagon because it looks bit professional if you have octagons. So there, if you yourself can see that it gives a good shape to your track. Okay, now our PCB is almost done except the ground connection. So for ground connection, what we do is we use this polygon. Now previously for a simple hobby projects you don't need this type of concepts. For that you can follow the previous tutorial of mine wherein we used to manually route the grounds. But if you are to design a professional PCB or a PCB which should be a high-speed board or something like that, then you need to use this methodology of ground planes. So in my next tutorial I'll be even discussing about the various strategies of grounding, various strategies of lines, track widths and all those things, but for now let me show you how to make a good ground plane. So generally when the PCB is a 2-layer board or a 3-layer board, so there is a ground plane, there is a VDD plane. Sometimes if there is a analog and digital circuit, so there is an analog ground, digital ground and all those stuffs. So presently here we are making a complete analog circuit. So what we can say is there is one ground plane. So let me have a lower width for now, let's say 0.6. okay, so I always like to start with bottom, so let's do this. So make sure that you end this wire exactly at this point, double click it, right, now you need to right click it, say name, and just name it as ground because in your this, okay, let me do this thing first. So it should be the entire signal. Initially it was this polygon, you should switch to the entire signal, say okay, say okay again. Now you can see that it has accept the signals, everything is grounded. Now always click a rat nest. Okay, now let me show you why I named it as ground, because this net of ground is named as ground. It could be some other name if you have named it differently over here, but since you have named it as ground, this is ground. Now you can see that these cross marks say that though these points are grounded, but you need to also ground this top layer, right? So I also want to have a ground plane in my top layer. So let me complete this. Let's say GND, the entire signal, say okay. So you can see now, as soon as I press the rat nest, my all those cross marks are gone and my PCB is all ready to be given for fabrication, and you then do those Gerber files and all those things. So if I want some decorative things, I can say Nishant Mittal. Okay, so I want this as T name. Alright, so let me write here, okay, tutorial 2. Alright, I want to change the size, I can always do that. Alright, now I want to say that this is VEE, this is VDD, and this is ground, so I can say VDD. Okay, sorry, VDD, VEE, and GND. Okay, now I hope I have covered this concept that if I want to delete this thing, yeah, I have already covered it while deleting the part for this. So I'll click on this smash, I'll click on this, then I will delete this SL2. Okay, so I think things are pretty much ready. Now you see that these PCBs are very good if you want to make it through a professional company, but if you want to make it at home, there is a chance that this track may get shorted with this one. So it's always good to have a greater gaps between them. So let me show you how to make those gaps. Let me delete these lines. Okay, let me make the lines once again. Now before making this line, this isolate is something which decides how much should be the gap. So let's say I want a gap of 1.06 mm between the ground and the track. So I did this, I'll say name, I'll say GND, I'll say entire signal. Okay, alright, now I'll click this. So you can see that now the gap is pretty much good, and it's very easy to fabricate this thing at home also. So I think that's all with this tutorial. In the next tutorial we'll be doing some more high-speed optimization techniques, grounding techniques, and we'll be wrapping up our tutorial series on Eagle based PCB design. Thank you for watching this video. You can subscribe my videos and share it for future references. Thank you.